All this is about is find the area of triangles and find the area of parallelograms. So, let's start with this. The height of the triangle is always... Oh, it's still on there. Silly me. Okay, always perpendicular to the base. The height of a triangle is always perpendicular to the base. I want you to draw a couple pictures. There's one picture. And the height here is inside the triangle. The height is inside the triangle. If you draw another one like this, a right triangle, if you draw a right triangle, the height is the leg. The height is a leg. Okay, and then if you might have a triangle that looks kind of like this, and there the height is actually outside of the triangle. The height outside the triangle. All right, definition for base is kind of funky. It's just whatever side the height is perpendicular to. So this would be the base, this would be the base, this would be the base. Whatever side the height is perpendicular to. All right, for the sake of time, we're not going to do 1, 2, and 3, but I do want to remind you about 4 here. Find the scale factor of a triangle A to triangle B. So we're going to go from A to B, just with corresponding sides. So this side corresponds to this side, so I'm going to say 6 is to 9. Same with this one, 6 is to 9. And 4 is to 6 down here on the bottom. If I reduce all these, lo and behold, they're the same number, which is the scale factor. Just as a refresher. That's the scale factor, okay? So, formula for area of a triangle. It can be written a couple different ways. The easiest way is this for what we're doing today. 1/2 base times height, because basically you're taking a rectangle, cutting it in half. That's a triangle, isn't it? So that's how you find the area of the triangle. You may often see it like that. That's fine also, but it works better for what we're doing to do this today. Okay. All right, and then the other thing we're going to look at is this little theorem here. It says if two polygons are similar with a scale factor of A over B, like for example here, 2 over 3, then the ratio of their areas would be A squared over B squared. So the ratio of these two areas would be 4 over 9. I squared them. So that's what that's saying. Hold on a second. All right, let's practice this. Couple things here. Let's find the area of the right triangle here. So here's the height. Here's the base. Let's just write down the formula and fill in what we know. So area equals 1/2. The base is what? 11, and the height is 8. And you do not need a calculator to do this math. Multiplication, you can go in any order, right? What's half of 8? 4 times 11. Isn't that nifty? You can multiply in any order. So it's 44. What would I put for units if I'm doing area? Centimeters squared. Be sure you do squared because we're talking about square surface area. Okay? All right. Turn it over. Same kind of thing here. Find the area of the triangle. So I write down the formula I'm working with. The base is here. The height is here, perpendicular to the base. So this is the base, this is the height. Let's fill in what I know. I know the base is 36 and the height is 12. You could do this without a calculator, but you don't have to. If you wanted to get a calculator out, I would put 0.5 times 36 times 12. Right? Where's the 0.5 come from? That, okay? And then just you put it on the calculator. You could do it on your head. You could do 6 times 36. I can do that in my head, but I don't expect that you have to do that. So 216. What's the units? Inches squared. Okay, it gets a little different now, not too bad. It says find the height of the triangle. Oh, I'm looking for h. I don't know what h is. Given that the area is 27. So they gave me the area. So I'm going to write down my formula because I'm working with the area of a triangle. Always write down the formula and plug in what you know. What's the area? 27. So I'm going to replace A with 27. Keep the 1/2. I'm going to look at my picture. Here's the height. Here's the base. What is the base? 9. Times 9. Do I know the height? I don't know it yet. I'm going to figure it out. What's half of 9? What? 4.5. Divide by 4.5, and I'm going to have my height. H equals 6. What? Correct yourself. Is it meter squared or is it meter? Just meter because I'm not looking for area. I'm just looking for the side length. So it's just meter. Okay? All right, so this is where we're going to look at that theorem on the other side. The first thing they're asking us to do is find the ratios of the areas of the similar triangles. So they told us it's similar. So I'm going to just name my triangles because I think it's a little easier. That's B and that's C. So I have to find the ratio of the areas of the similar triangles. So I'm going to start with finding the area of triangle B. So area equals 1/2 base times height. The base here is 12 because the height is perpendicular to it. So even though it looks upside down, it doesn't matter. That's still my base. So area equals 1/2 12 times 9. Half of 12 is what? 6 times 9. 54. I don't know the units, so I'm just going to leave it at that. Then I'm going to find the area of triangle C, same way. And I've got 1/2 of 20 times 15. What's half of 20? Times 15. See how you can do that in your head? Isn't that nifty? All right, now it says I have to set up the ratio of the areas. So I'm going to do triangle B over triangle C. The area of triangle B is 54. That's just a scribble mark. 54 over 150. It's the ratio of their areas. 54 over 150. If I reduce that, I get 9 over 25. I'm going to write a little note to myself. That's the ratio of their areas, just so I remember. Now this says find the scale factor of triangle JKL, or RB, if you want to call it that, to RST, our triangle C. So I'm going to look, well, corresponding numbers. I could do the height to the height and the base to the base, and that'll probably help me find the scale factor. So I'm going to do height B to height C because they told me I have to do the little one to the big one. Okay, so got to set it up that way. So the height of B is 9 over 15. 9 to 15. And that reduces to 3 over 5. So there's the ratio of the heights. Now I'm going to try the bases to see if I get the same number. Base B to base C. And that would be 12 over 20. Oh, look at that. It reduces to 3 over 5. So that's the ratio of corresponding sides, or my scale factor, if you want to say that. So I'm going to say that's my ratio. Okay, then it says compare it to the ratio of their areas. 3 to 5. How does it compare to 9 over 25? How can I get from 3 to 9 and from 5 to 25? Yes, Serena. Oh, if I square them. 3 squared and 5 squared gives me the ratio of the areas, doesn't it? That's exactly what that theorem was saying on the other side. If I square these, this the ratio of the sides, I'll get the ratio of the areas. So that's kind of what it was. That's the theorem we were looking at on the other side. Okay? So that's really what I wrote ration here. What was I thinking? Sorry. So there's that. Find the area of the parallelograms. Let's just draw a picture to remind ourselves what a parallelogram looks like. It's kind of like that. The sides are parallel. The base of a parallelogram is going to be either pair of parallel sides. So that means that this could be the base, or if I twist it like that, that could be the base as well. It doesn't really matter in a parallelogram. All right, the height of the parallelogram is the shortest distance between the bases. And it's always perpendicular to the base, or bases, if you want to call it that. So I could draw it like this, or it could be outside, like that. Doesn't matter. You might see it either way. All right, let's just jump down here and we'll start the notes here. So, area of a parallelogram is really just taking a rectangle and slanting it a little bit, isn't it? You take a rectangle and it's kind of a slanted rectangle. Still the same area formula. Yeah, it's like you pushed it. Area equals base times height. Same formula as a rectangle. Now, to be honest with you, when I got to rhombus, I'm like, I don't know. I don't think I've ever done that. I don't remember. So I had to look it up. Here's the rhombus. What I know about a rhombus is the four sides are equal and their diagonals are perpendicular to each other. Oh, wait. What did I just say? What's this called? What's that called? Starts with a D. Diagonal. Remember? So this is diagonal 1. And this would be diagonal 2. Not that it matters which is which, but just know that there's two diagonals. And so the formula for area of a rhombus looks like this. Area equals 1/2 times D1 times D2. Interesting. So let's just work with both of these. Find the area of the parallelogram. Okay, parallelogram is base times height. I'm going to plug in what I know. 13 times, what's the height? 5 equals 65 what?
Feet squared.
Right on. Feet squared. Okay, turn it over. Okay, find the base of the parallelogram given that its area is 486 square inches. I don't know the base. They gave me the area. So if I'm working with area of a parallelogram, I just write down the formula and plug in what I know. Substitute. I know area is 486, so I'm going to substitute A with 486. Do I know the base? Don't know what that is yet. But I know the height is 27. So if I divide both sides by 27, I'll get what I'm looking for, which is 18 what? Thank you. Please don't say squared, because it ain't. It's just inches. It's just a one-dimensional measurement here. Okay, let's work with rhombus and then we'll be done. Find the area of the rhombus. So you figure out what that formula is and you write it down. And then you fill in what you know. So if I look at this picture, I don't know the area. I could say this right here is my diagonal 1. And how long is that? 18. And then I could say this distance right here is my diagonal 2, which is how far?
15.
Right. And then I just multiply. Half of 18 is 9 times 15. Can anybody do that in their head? Somebody whipped it out last hour. I couldn't believe it. 135 centimeters squared. Okay, last one here. You got to piece some stuff together. It's a rhombus. So I'm going to write the formula down. Plug in what I know. I don't know the area. I know that's 1/2. Now I got to look at this. They're giving me part of the diagonal here and the other part here for a total of how big? 28. 14 and 14. So one of them is 28. And then they're giving me a piece here and a piece here for a total of 10 for the other diagonal. Don't need a calculator. What's half of 28 times 10? 140. Inches squared. I'm not going to do the last problem with you.